Okay, this is Unit 5, Day 1, an Introduction to Trig. And you will see on your screen here shortly the objectives that I would like you to be able to do at the end of this lesson. And we will start with ratios of right triangles. The first thing you need to remember is that a right triangle has one right angle designated by the small square in the corner of the right angle, and the two sides that form that right angle are called the legs. So we have the leg A and the leg B, and then the hypotenuse, the third side, is the longest side. It's usually given by the letter C, and it's usually called the hypotenuse. Now, trigonometric ratios are ratios of the sides of these right triangles. For instance, if we look at angle A and we look at the side opposite angle A, which is labeled with a lowercase a, and we look at the hypotenuse, which is labeled with a lowercase c, we can say the ratio of those sides is A over C. And the interesting thing is, whenever you have a particular angle, say a 30-degree angle, it doesn't matter how big your triangle gets, the ratio of side A to side C is always the same number. It will always be that way. Likewise, we could find the ratio of the side that was adjacent to side A, to angle A. So here's angle A. The side that is adjacent or makes up part of that angle but is not the hypotenuse, well, that is side B. And then, of course, the side that is the hypotenuse is side C. So the cosine of A is the ratio B over C. And again, no matter how big we make this triangle, the ratio of B over C of a particular angle, say 30 degrees, is always going to be the same thing. And finally, the tangent of angle A, again we're looking at angle A, well, the tangent is the side opposite angle A, so that is side A, and then the side adjacent to angle A, which is side B. So the tangent ratio is defined as A over B, or side opposite to side adjacent. Now, most of you probably know that there's an easy way to remember this, and that's called SOHCAHTOA. And so this is a mnemonic, there we go, to help you remember that the sine function is the ratio of the opposite side to the hypotenuse, so that's so. Sine is opposite over hypotenuse, SOH. The cosine is the side that is adjacent over the hypotenuse. So cosine is adjacent over hypotenuse. And then the tangent function is the side that is opposite over adjacent. SOHCAHTOA. Now, I put these in little what I call equation finders, and that's just a way that if you struggle with algebra or you just don't want to have to think about it, it'll get you past math. And let's look at how this works. Let's say the area of a rectangle is the length times the width. We know that. Well, if I know the area, let's say it's 10, and I know the width, let's say it's 2, and that's in meters, it's easy to see that to solve this formula for the length, we take 10 divided by 2 and get the width. It just gets you past the math, so you don't have to think as much. Okay, so converting between angles and trig ratios. So if side A, and I'm going to label this here, is 21 meters, and side B is 25 meters, the tangent ratio in regards to angle A, that's the angle I'm looking at, the tangent ratio would be tangent opposite over adjacent, TOA. The opposite side, the tangent of angle A, would be the opposite, which is 21, divided by the adjacent, which is 25. And so that would give us a ratio of 0.84. But let's scale the sides up by a factor of 2. So let's make side A twice as big, so it's now 42 meters. And let's make side B twice as big, it's now 50 meters. The tangent ratio, which I will figure again, in regards to angle A, is 42 divided by 50, which is still 0.84. That tangent ratio, 0.84, is always associated with a particular sized angle. And so we can switch back and forth between the tangent ratio decimal and the value of the angle. And so that's what I have written down here for you. The tangent is the opposite over the adjacent that gives us a decimal value. And the case that we have been getting for when we've used these sides is 0.84. But if we want to know what particular angle is associated with that decimal value of 0.84, we use what's called the inverse tangent. And on your calculators, it'll be a tangent with a -1 power. It's called the inverse tangent. And so that means if I give the decimal value 0.84 and find the inverse tangent, it will tell me that the angle is about 40.03 degrees. And so make sure that you're able to go back and forth on your calculator, that you can find the decimal ratio, which is just a division problem, 21 divided by 25, but that you can take the inverse tangent of that decimal, 0.84, and arrive at the angle of 40.03 degrees. So you need to be familiar with the trigonometric ratios. And I will ask you to find all sides and all angles of a triangle. So, given this triangle, I have a side that is 5, a side that is 12, and one right angle. And again, trigonometric ratios only work with right triangles. You can't use any triangle. So, the first thing I'd like to do is find side C, and I'm going to choose to use Pythagorean theorem just because that's a little bit easier. Now remember, Pythagorean theorem is a squared plus b squared is equal to c squared, where c is the hypotenuse. So 5 squared plus 12 squared is equal to c squared. That means 25 plus 144 equals c squared, or 169 equals c squared. The square root of 169 is 13, so side C is 13. So that's the easy way to find that. Now let's find the sine of angle A. So we look at angle A. From angle A, what are the opposite and the hypotenuse sides? And so looking at my diagram, the side opposite angle A is 5 units long. The hypotenuse is 13. That decimal ratio is 0.3846. Now find the cosine of angle A. That's the relationship of adjacent to hypotenuse. Excuse me. So again, looking at angle A, the adjacent side is 12. Means it has to make up one side of angle A and not be the hypotenuse. So that's the side that's 12 units long. The hypotenuse is 13. So that decimal ratio is 0.9231. The tangent is opposite over adjacent. So again, looking at angle A, the side that's opposite is 5. The adjacent side is 12. That ratio is 0.4166. Now, we could use any one of these to find angle A. I'm going to use tangent just because it's one people don't always often choose. So the tangent of some angle A is 0.4166. So the inverse tangent of 0.4166 will give me angle A. And if I do inverse tangent, I should get pretty close to 22.6 degrees for angle A. Okay, I'm going to back up just in case you didn't get enough time to write everything down. Okay, what I would like you to do is to take a few moments here, and I want you to find all the missing parts of this triangle. So pause this presentation. Okay, I hope that you're back now. So, to find all the missing parts, one of the first things is to realize that a triangle has 180 degrees. The angle given as C is 90 degrees. Angle A is 40 degrees, so that's 130 degrees. Angle B must be 50 degrees. Remember, angles are given with capital letters. Sides are given with lowercase letters. Make sure that when you draw your triangles that letter A, the side, is opposite or across from angle A. Likewise, letter B, the side, is opposite or across from angle B. Now we need to use a little bit of trig to find missing information here, and I think I'll use the cosine function this time. And so the reason I chose that is if I look at angle A, I know side B, which is the adjacent side, and I would like to find side C, which is the hypotenuse. And the relationship that links adjacent side and hypotenuse is the cosine function. So the cosine of angle A will be the adjacent side, 150, divided by the hypotenuse. And I know that angle A, I'm going to put that in here, was 40 degrees. So what I need to do is take 150 and divide by cosine of 40 degrees, and when I do that, I get 195.8. So side C equals 195.8. We were working in units of centimeters. So there is side C. Now I'll work on finding side A. And there's many different ways you can do this. You could use Pythagorean theorem. You could use trig functions again. So I think the way that I'll choose to do this to find side A is to use the trig function. So I'm dealing with the opposite side. I know my adjacent side, that would be the tangent function. So the tangent of a 40-degree angle is equal to the opposite, which is side A, divided by the adjacent side, which is 150. So all I need to do now is take 150 times the tangent of 40, and that gives me 125.86 centimeters. So we can plug that in, and everything has been solved for side A, B, and C, and angle A, B, and C. Okay, trig question. What is the value of the tangent of angle A? So circle what you think the correct answer is. Pause this presentation. Okay, you're back. The correct answer is 5/12. We need to be looking at angle A. Tangent deals with the side that is opposite and adjacent. The side that is opposite A is 5. The side that is adjacent to A is 12. Remember, the hypotenuse does not count as an adjacent side, and the hypotenuse is the longest side of a right triangle. Okay, given right triangle ABC, where A is 10 and B is equal to 15, find the measure of angle B. Round your answer to the nearest tenth of a degree. And so I'm going to just make a quick sketch. Angle A, angle B, angle C, and I think I advanced forward one. There we go. Back on this first one where A is equal to 10. Angle A, angle B, angle C. This is a right triangle. A is across from angle A, and that's 10 units. B is across from angle B, and that's 15 units. And we would like to find the measure of angle B. So I was given the opposite side and the adjacent side, and that's the first thing you need to do. You need to figure out what side you were given in relationship to your angle so you know which trig function to use. And I know the tangent function deals with opposite and adjacent. So the tangent of angle B will be my opposite side of 15 divided by adjacent side of 10. So the tangent of angle B is equal to 15 divided by 10, or 1.5. So the inverse tangent of 1.5 of the decimal number will give me the degrees, and that would be 56.3 degrees. Okay, this one is for you to do. I've already drawn the right triangle. You need to label what you've been given and find the length of C. Go ahead and pause this presentation. Okay, I assume you're back now because you finished it. We know that angle A is 20 degrees. We know that side B, which is opposite from angle B, is 35 feet, and we would like to find side C rounded to the nearest tenth of a foot. The angle I was given was angle A, and in conjunction or in relationship to that angle, I was given the hypotenuse side and I was given the adjacent side. Remember, the hypotenuse can never be adjacent. So, what trig function relates adjacent and hypotenuse? That's the cosine function. The cosine of an angle is the adjacent side over the hypotenuse. So the cosine of 20 degrees will be the adjacent side of 35 degrees over the hypotenuse, which is what I don't know. So I need to take 35 divided by the cosine of 20 degrees, and when I do that, I arrive at the value for 3 is 37.2 feet. Okay, that was Unit 5, Day 1.